Today we're going to be doing a problem using optimization. Optimization is used to find your maximum or your minimum value for a certain whatever it is. It could be the maximum fence you need, it could be the maximum amount of money you need, building blocks, whatever, or the minimum. The minimum cost. It can be used for any of the following reasons. Today we're going to be doing an example using a barn. We have a sentence using a barn as an example. We have 100 yards of fence. We are trying to enclose sheep. So I will build my fence along one side of the barn. How big should the fence be to maximize the area for the sheep to be enclosed in? What we're trying to do is find the maximum area. So what I'm going to go ahead and do is, remember, along one side, I'm going to draw it like this. And this is just a little fence. I'm going to name these two sides X and that one side Y. Okay, if you remember 100 yards, and you can use the formula, which is A equals X times Y, in which case here we have two X's, so 100 equals 2X plus Y. And we can change that to equal Y equals 100 minus 2X. We're going to use this later on. For right now, I'm going to plug in 100 and 2X and use this for my area formula. So, now what I have, after I plug this in, I have X times 100 minus 2X in parentheses. I'm going to go ahead and distribute my X. Now I have 100X minus 2X squared. Okay? Take the derivative of that, and now I have my A prime. My A prime is now equal to 100 minus 4X. Well, what does that do for us? We can go ahead and set that to equal 0 to find out what is X equal to. So we go ahead and do that, do some math, and then we find X is equal to 25. Okay? And you can go ahead and find your A double prime. So, now we have A double prime and X. Let's go over here. We can go ahead and say our maximum is 25, and we're going to plug our X into our original equation for what Y is equal to. So Y is equal to 100 minus 2X can be thought of as Y is equal to 100 minus 2 times 25. Now we're going to do some math. Now Y is equal to 50. Remember our original equation. Area is equal to X times Y. This whole time we've been trying to figure out what is X and what is Y. So we can go back to the original area equation. So now we come back over here. X is 25 and Y is 50. You multiply those two together to find your area is actually equal to 1,250 yards squared. And that is the maximum area for your sheep to be enclosed in. Like I said, you can use optimization for many things, many different optimizations, like I said, for cost or for how much you need, but in essence you can use it for stuff. Alright, so just an overview of everything that we did. Remember, we're doing optimization, we're trying to maximize the area for the sheep. Your area formula was X times Y. The whole point of doing all this nonsense was trying to figure out what is X and what is Y. You took your 100 yards and set it equal to, you have two X's plus one Y, and then you turned it into this to figure out Y is equal to whatever this is equal to. You went ahead and took your first derivative, and then once you found your first derivative, you set it to equal 0 to find out what X is equal to. And also your A double prime, which may or may not be useful depending on what kind of situation you're in. So you find your X, then you go try to find your Y. You plug X into this equation, so then you got 100 minus 2 times 25. You found out your Y is equal to 50. And then you found your Y, you have your X, set your area X times Y, and there you go. And that's your maximum value.